In today's tutorial, we are going to detect basketball players. As you can see in this image, we are detecting Real Madrid players, Maccabi Tel-Aviv players, the referee, and also the ball. But instead of detecting it on an image, we are going to do something more complex. We would like to run a YouTube video of a gameplay and detect the players, the game, and the referee on the fly. Yes, and we are going to do it without a dataset. So in order to achieve this training, we will extract information from another video of a gameplay, extract the frames, build a process of automatic labeling, and then train a model and run it on a new test video. So let's see first of all our test video. Let's run it on YouTube. A simple video of a game between Maccabi Tel Aviv and Real Madrid. As you can see, there are white players and blue players, and also the crowd, the ball, and two referees. And let's jump to the result after the tutorial, and you will see the amazing results of our training. Now watch the result. As you can see, this is the same game, and we are detecting on the fly, live, the players. We're detecting the referee, as you can see in the upper left corner, and also we are detecting the white players as Real Madrid players. We're also detecting the blue ones as Maccabi Tel Aviv players, and also the ball is being detected. Let's do a zoom in. You can see that it works fine when we do a zoom on the players. So in this tutorial we are going to explain the full process. This tutorial is part of a playlist that explains many types of object detection methods. You are most welcome to see more of those videos here in this link. And I really recommend you to subscribe my channel. More videos will be uploaded soon. So let's start with the first step, which is the installation part. As always, if you are following my tutorials, the first part is the installation. So we will create a new and fresh Conda environment, and this will be the name Autodistill, and as you can see, it will be based on Python 3.8. All this of course will be under the Anaconda command prompt, and after creating your environment, you should activate the environment using the conda activate command. And then in order to download PyTorch, you should check out what is your CUDA version by typing mvcc ---- version. Mine is 11.8, so this is the command in order to install PyTorch 2.1.1 version. Of course, if you have a different CUDA environment, different CUDA version, you should look for the relevant PyTorch version and download it. You can copy from the PyTorch website, you can copy the relevant command for installation of PyTorch. Next, we should install 3 more Python libraries. The first one is the YOLO v8.1. So we are using pip install Autodistill equal 8.1.0. Of course, there are a newer version, but if you would like to follow my tutorial, it's better that we will have the same version. Then we will install 2 libraries that help us to stream videos from YouTube. So you should pip install both Python libraries. I don't know yet which one I will use, but basically you should install both of them, and we will use it later. So this is the basic process of the installation, and let's move to the next step. The next step will be generating a dataset. Basically, we don't have any dataset of Maccabi Tel Aviv players during a game, and also Real Madrid players. So let's go to YouTube, and we will take one of one of the video that described the game between Maccabi Tel-Aviv and Real Madrid. Let's play this video. As you can see, it's about 4 minutes video, and let's make it silent. So this is the game between those two teams, and we will take this video and we will extract all the images from this video, and then we will do some automatic annotation for both teams. And let's take the second video. Let's stop this video and go to this one. This will be the second video. Once again, let's play it. Let's make it silent. It's a 5 minutes video, and as you can see, once again we have both players, and this is the game, and we will do the same process. We will extract the images from the second video as well, and we will do an annotation, an automatic annotation, in order to create the dataset. And after all this finish, and we will do the training as well, we will take a third video, and this video will be our test video, and we would like to do the main target will do an detection on the fly. So we would like that our model will detect in real time, running the inference of our trained model, and we would like to draw a bounding box around both teams. So all the players of Maccabi will be labeled as Maccabi, and the players of Real Madrid will be labeled as Real Madrid. As you can see, Maccabi it's the blue shirts and Real Madrid is the white shirts, but we would like to do an automatic annotation. After that, build the model and run the inference. This is the target of our tutorial. So let's start with extracting the information. Let's create a new Python file. It will be step number 1, and it will deal with extracting images from the YouTube videos. We start with importing the necessary libraries. CV2, it's OpenCV for image processing, and OS for interacting with the operation system. The CamGear from VidGear library, which allow us to easily capture and process live video streams. Next, we define the list train URLs containing the URLs of the YouTube videos that will be used for our training. We initialize variable numerator to 0, which help us to keep track on the number of frames processed and give each image a unique name. We set output path images to define the directory where the extracted images will be saved. And next, if this directory does not exist, we create it using the OS-makeDirs function. This will ensure us that we have place to store the frames extracted from the videos. Now we will loop through each video URL in the train URLs list, and this for loop will handle each video one by one. We initialize the CamGear stream with the URL of the video, and we set stream mode true to indicate that we are working with a video stream from an online source, and enable login is for debugging purposes. And inside the loop, after that we initialize the stream, we are creating another loop, and this loop will be a while true loop statement to process the video frame by frame. We use the stream read method to read the next frame from the video stream. And if no frame is returned, it's probably we reach the end of the video and we break out the while loop. Next, we construct the output file path for the current image. The image name is dynamically generated using the numerator variable to ensure each file has a unique name. Next, we resize the frame to 640 by 640 resolution, and this will help us reduce time during the training, since the YOLO works better with these dimensions. We save the resized frame as an image file to the output path using the CV2IM write. And next, we overlay some text on the frame to display the image number. This is how can we see the progress of the frames. So we basically are going to see the numerator on the screen each time we go to the next frame. This will be helpful with debugging. Next, we display the frame using CV2IM show. And in order to break the process, if a Q key is pressed, then we break out the loop and stop the video processing. Once all the frames has been processed, we release the video window and stop the video using the destroy windows and stream stop. Let's run it. As you can see, the numerator number, and basically we are extracting all the information to the directory. Let's go inside. You can see here all the images, and they are in a new dimension, 640 by 640. Okay, let's continue to the next step. Let's see the result. The process has finished, and as you can see here, we have more than 14,000 images. A lot of images. So we have a lot of data for training. But may I remind you, before the training, we are going to do an automatic annotation. Let's see the result in our folder. So we store it on dataset, Maccabi Real subfolder, and inside it we have another images folder, and you can see here we have 218,000 images. And as you can see here, we can open one of those images, and you can see that the images were resized to 640 by 640 because this is the relevant dimensions for the YOLO V8 model. So basically the YOLO V8 model can deal with any of those images. Is doing the resize before the training, but if we would like to reduce the training time, we can do all the process before the training, and this is what we have done here. So let's continue to the next step. Let's move forward for the next step. It will be step number 2. We should do it here. Step number 2, and it will be an auto label the dataset .py. Okay, let's start from Autodistill .detection. We would import the caption ontology. It will help us to define our text that will be run over all the images and create those annotations. So now let's define this ontology. So ontology equals caption. We will use the function, the object, and let's now define all the relevant texts. So the first category that we would like to generate will be a basketball player with blue shirt. So we would like that the Autodistill will look for, in the image it will look for basketball players with a blue shirt, and we will name it Maccabi player. So this will be our first category. The second one would be very similar, but it will be a basketball player with a white shirt. As we saw earlier, Maccabi wears a blue shirt and Real Madrid wear a white shirt. So this would be Real Madrid player. And let's also look for the ball. Let's now do the ball, basketball, orange ball. And this would be our ball. This would be our category. And the last one should be a person with black or orange shirt. And this will be our referee. Okay, I forgot to add here comma, and here as well, and here as well, and that's it. Great. So this would be our dictionary for ontology. Now let's initialize the process with several variables. For example, the path for the source images and for the result dataset. So let's define image dir path. This is the path for our images. So let's copy the path. This is the path. We will change the direction of the slashes, and that's it. Now let's also define the dataset path. So the result will be stored here. Path. Let's put it on our dataset, and let's name it dataset. So under this subfolder named dataset, we will contain all the results, all the annotations of our images. Let's define a threshold for our text and for the bounding boxes. Let's start with 0.3. Of course, we can reduce the number, and we will discover more of the people with the basketball player with blue or white shirt, but I believe that maybe it will also get some, let's say, a noise and discover an unrelevant object. So I believe that 0.3 should be good enough. If there is any problem and we will discover more object, we can make this value higher. And let's also for the text threshold, let's put the same value. And now let's initiate our base model. Autodistill GroundingDINO, import ground. This would be our pre-trained model for doing the annotations. And let's create our object. Base model equals GroundingDINO, and we will send several arguments. Our ontology, the one that we just defined, and also the thresholds. The box threshold will be for the box, and the text threshold will be for the text. So this is our instance of our object with all the parameters, and now let's run it. So let's run the process. It will be base model, and we will run the function label. And our input folder is the folder with the images, so this one. And extension, we would like that it will detect only files with the suffix png, and the output folder would be our output folder, this one, dataset folder. And I believe that's it. I hope I don't have any syntax error or other problems. I believe that we are ready to run it. Let's start. Let's wait a few more seconds. We are expecting for a progress bar. Let's wait a few more seconds. And here it is, started. So basically, as I mentioned earlier, it tries to take the text that we provide for all the 4 categories, and it runs each of the images, and it will create an automatic labeling. So after the process will be ending, we will have all the images with annotations. So let's stop recording here. Probably it will take about an hour, hour and a half. So let's jump to the final step. Let's jump to the folders and see the results. This is our main folder, Maccabi Real, and this is all our images. And the process has generate a subfolder named dataset. So it's generate train subfolder and validation subfolder. This is the most important one. Let's go for the train subfolder. You can see inside it we have the images and labels. So it's not only generated labels, it's automatically split the data for train data and validation data. So we are ready for our training. Let's see, for example, the subfolder of the train images. As you can see, these are all the images from our source folder. What's more important, we can go to the labels. And here we have the same names as the images, but the suffix is a txt. And if we double click for some of the, let's for example choose this one, as you can see here we have 1, 2, 3, 4 detected objects in image 155. We will open this image, but it's important to understand what we are seeing here. And we basically annotated 4 objects that are categorized to 3 of them. So for example, the first detected object, or the first annotation, is annotation 0. Let's see what is 0. If we go back here, this is 0, this is 1, this is 2, and this is 3. So basically, if we will open image 155, we are expecting to see 1 Maccabi player and 2 Real Madrid players, and 0, 1, 2, 3, and 1 referee. Hopefully that the data is annotated correctly. Let's hope that this is the situation. Let's try to open this image 155. Rain images 155. Where is it? Where is it? 155. So as you can see, there are more players, but this specific automatic labeling detected those, in those players, it detected, let's go back, detected 1 Maccabi players, 2 Real Madrid, and 1 referee. So here's the referee, you can see it here, and probably one of those Maccabi players was labeled. It's really important. This is not the detection, this is the labeling. So it's not have to be accurate here, because we are going to run the model, and we will teach the model how to detect a Maccabi player and a Real Madrid player. So basically we need a sample of the data, and let's move to the next step. It will be more clear what we have done. I add this code. It will be part of our it will be part of the whole code of this tutorial, and of course I will leave a link at the video description for all the code. And this code is just displaying random images. So I will display 4 random images, and this code basically what it's doing, it we are sending the folder for the images and folder for the labels. And if you look at this code, it runs through a loop of loading 4 random images and display those images, and also it get the annotations for those 4 images, and then convert those. So it's doing here it loading the txt file, and then convert it to a pixel, and put a rectangle around all the object, and also put the label name. Let's run it and it will be more clear. Let's run the code. So this is, for example, the first random image. As you can see, it detected here a Real Madrid player. Here is another Real Madrid player. Here is a Maccabi player. Here is the referee. And let's choose another one. The second one. This is the second random image. As you can see, this was labeled as Maccabi, as Real Madrid, another Real Madrid, this is Maccabi. So basically, it's a very good auto labeling. Although, for example, it didn't detected this one and didn't auto label this one, but it's not really important. Let's go for the third image. You can see here it was also auto labeled the ball. Here is a Real Madrid player. This is a Maccabi player. This is another Maccabi player. So I believe it will be a good data, so we can use this data and do all the training. So then we will take a new and fresh video and we will try to run it on the fly. You can see here this is a Maccabi player. Also we have a labeling for the ball, and this is a labeling for the referee, and this is a Real Madrid player, and this is a Maccabi player. I believe it's a very good data. This is a sample. Of course we can run it again. We will get another 4 random images, but we don't need it right now. Let's go for the training. Before training the model, we have to create a configuration file named data.yaml. We will put the path, the full path for our train images. So let's copy and paste it. And just don't forget to change the direction of the slashes. And then we also add the valid path, the valid images. And next we have to define the classes. So we have 4 classes, and now we'll define the names. The first name will be Maccabi player. This will be class number 0. Real Madrid player will be class number 1. The ball will be class number 2, and referee will be class number 3. 0 to 3, we have 4 classes. Now we are creating our Python code for the train. So we will start with import the YOLO class from the Ultralytics library. This library provides easy access to YOLO V8 models and object detection tasks. We define our main function where all the key operations will be happen. We load the YOLO V8 model using the small model. Please notice 8S, S for small. This model will train our basketball dataset. Next, we specify the path to our custom data configuration file, the one that we generated earlier. This YAML file contains information about our dataset, including class name and file path for the training and the validation. Next, we also define a directory path for saving model checkpoints. And basically the checkpoints and experiment results. The project path specifies where the checkpoints will be stored, and the experiment is the name of this specific run or experiment. Next, we set up the batch size for 32. This determines how many images will be processed in each training step. If you have memory issues, reduce the number to 16. Now we train the YOLO V8 model by calling the train method. We pass the following parameters. Data is the path for the configuration files. Epochs, it's the number of epochs. Let's define it as 300. Project and name, we defined it earlier. Name and a batch is the batch size of the training. Device specifies which GPU or CPU we are going to use. Device 0 means we are going to use the first GPU. And image size, it's 640, and val means whatever there is a validation model during training, we set this to true. Finally, we run this command. Let's run the training. The model was loaded. Now we are loading the train images. And next we will load the validation images. Here it is, and let's start training. So basically we are not going to wait 300 epochs. It can take several hours, so let's jump directly to the last epoch and see the results. So the training has finished. Let's see the results. Everything was stored in this checkpoints subfolder, and inside it our experiment name is small model. And let's open this subfolder, and first of all let's see the results. If we open this file, we can see that let's look here in the train class loss. We can see that it's going down. It's a very good sign that our model is generating good results. And let's also see here this matrix. If we go here to the precision, we can see that the precision go up from 0 to 1. This is also a good sign that our detections will be good ones. Let's close this file. And another important issue is to understand that everything, the weights are stored here in this weights subfolder. We can see two files, one named best.pt, which is the best weights of all the epochs, and last.pt that contain the weights of the last epoch. Let's also look at these images. Let's, for example, open this one. val underscore batch 1 underscore prediction. It contains a bunch of images, and let's, for example, enlarge this one. Okay, this one. As you can see, it detected the referee, it detected Maccabi player. It's hard to see because everything is like stuck together, but we can see here that it detected a referee with an accuracy of 0.4. And here it detected this is white person is a Real Madrid player with a precision of 1. Well, very good precision. So I believe we are ready to continue to the last phase, which is testing our model on a live video. So let's create a new Python file. This will be step number 5. It will be test our model on a video. We will start with importing the necessary libraries, OpenCV and YOLO from Autodistill. And next we will specify the URL of the test video on YouTube that will run inference on. Let's copy. Let's see, first of all, let's see this video on our browser, just to double check. Yes, this will be our test video, and we will try to predict the players on this video. Now we construct the file path to our training YOLO model weights. Let's copy this, the path for the checkpoints, and we have to add our project path. We name it small model, and the weights under small model and best.pt is the file. We load our train YOLO model using the path to the weight file. This model will use to detect the players, referees, and the ball in the basketball game. Let's define the threshold to 0 to 25. This means that only detections with confidence score higher than 0.25 will be considered. We use the CamGear to stream the YouTube video, same as our previous code. Then we enter a while loop that continuously reads the frame from the video stream. If the frame is none, that means that we finish the video and we can break the loop. Then we pass each frame through the YOLO model to detect objects, and the results object contain all the detection of the current frame. Then we iterate over the detection results. Each detection contains bounding box coordinates, the confidence score, and the class ID of the detection object. Next, we convert the bounding box coordinate from floating point values to integer. And if the confidence score for the detection is greater than our threshold, we draw a bounding box and label it with the detected class name. So the rectangle function requires the image, the coordinates for the rectangle, the color, and the thickness of the rectangle. And here we are adding the name of our detected class. We get the list of the names out of the results variable, and then send in the class ID and convert it to the full category name. And then we will put it on the same image, a little bit above our rectangle, about 10 pixels above it. And at last we are displaying the frames one by one, and then we basically see a video with all the detected objects. We break the loop if a Q key was pressed, and at last, after processing all the frames, we close the display window and stop the video stream. Please notice I have an error here. It should be small minus model. So let's run it and see the result. So here is the same test video, and now you can see a green bounding box around each of the players, and also a text with the class name, the white players. There is a Real Madrid player, and around the blue there is Maccabi Tel-Aviv player. And also please notice that we are detecting the referees and the ball as well. Pretty good detection. Thank you very much. Please subscribe my channel and click the notification bell. Bye bye.